If you've ever tried stringing multiple AI voiceovers together, you know the struggle. You generate a paragraph, it sounds great, but the next paragraph suddenly shifts pitch, drops its accent, or changes pacing entirely. To solve this, we'll build an audio pipeline that locks down a specific persona, ensuring uniform output across hundreds of separate API calls. We will execute this in 3 steps: selecting the most cost-effective model, prototyping the voice behavior, and locking configuration into our code. Before we begin, you need a Google Cloud account with billing enabled and a basic understanding of either Python or Node.js. Maintaining this technical consistency ensures your narrator remains recognizable from the first sentence to the last. Inside the Vertex AI environment, your first decision is balancing audio fidelity with your API budget. This comparison chart lays out our options. Chirp 3 HD offers 1 million free characters monthly. Premium upgrades like Gemini 3.1 Flash and 2.5 Pro use token pricing: $1 per million input tokens and $20 per million audio tokens. You should scale up to these token-based models when your project requires deep emotional resonance or multi-speaker dialogue within a single generation. Selecting the correct model upfront dictates your financial runway and sets the ceiling for how expressive your final application can be. With our model chosen, we move to the Google AI Studio Audio Speech Playground, shown here. We will use the director's chair controls here as a sandbox to test voice characteristics. You can force the AI to act out specific emotions by typing inline audio tags, like brackets around laughs or whispers, directly into your prompt. However, pushing a massive 10-minute script into Gemini 3.1 Flash TTS in a single request frequently triggers a timeout error. To mitigate this for long-form content, you must either chunk your text into smaller paragraphs or swap back to the Gemini 2.5 Pro TTS model. Prototyping in this interface allows you to perfect the acting logic before you hard-code API behavior. With the voice perfected in browser, we must replicate those exact parameters in your local environment. Relying purely on text prompts causes a technical drift. The model interprets every request in isolation, which naturally leads to shifts in accent and delivery. This animation illustrates the solution. Instead of just sending text like the top example, we use the AI Studio export code feature. This wraps our text in strict speaker-level specificity parameters, resulting in the incredibly smooth, controlled output seen on the bottom. Exporting these exact parameters ensures the voice maintains character across completely independent sessions. Looking at this code editor, we have our basic script with the Vertex AI connection initialized. Step 1 is to scan the exported API payload and locate the speech config object. Within that object is the voice config dictionary. As highlighted here, the voice name variable, currently set to Puck, is the exact line that controls the persona. You can slot other specific voices, like Zephyr for a bright delivery, or Karen for an informative read. To thoroughly test our configuration, we will write 2 drastically different text inputs: a friendly greeting and an angry complaint. We will pass both through the exact same voice config payload in 2 separate calls. Hard-coding the persona at the JSON level separates the actor from the script, forcing the AI to maintain identity regardless of the dialogue. Here are the results of those 2 distinct API calls. Despite opposite emotional tones, the pacing, accent, and vocal timbre remain perfectly identical. As an added security layer, all audio generated through this pipeline is automatically embedded with a SynthID watermark to track authenticity. You now have a scalable, budget-friendly audio pipeline that serves as a reliable foundation for video games, customer service agents, and professional audiobooks. Check the video description for links to the Google Cloud pricing page and the exact code snippets we use today.